of lines. Last week we talked about the angle sum theorem, and we learned that all the interior angles of a triangle add up to equal what? 180 degrees. We also talked about when you take a triangle and you extend one side of it, you get an exterior angle, right? So it's created by the extension and one side of the triangle. What did we learn about this exterior angle? It's equal to the sum of the remote interior angles, right? Then we talked about slope, okay? And we said that slope was the steepness of a line, and that to find slope is the difference in the y's over the difference in the x's. But you can find slope from a graph. You can find slope from an equation. And so today we are going to look at equations of lines, how slope is involved, and then tomorrow we're going to talk about parallel and perpendicular equations. But anyway, so today we're talking about the equations of lines. Now the equation of a line can take on a lot of different faces. We have the standard form, which is ax plus by equals c. Okay, that's the standard form for the equation of a line. You basically have an x plus a y equal to a constant. The a, b, and c just represent coefficients or numbers. Okay. If you take and rearrange it in different forms, it's helpful. One such form is the slope-intercept form. If we can take our original, standard equation and rearrange it so that it's solved for y, that puts it into slope-intercept form, and we can identify the slope of the line. We can identify the y-intercept. Okay. What is a y-intercept?
Where the line crosses the y-axis.
Where the line crosses the y-axis. So if we look at this equation right here, my y equals mx plus b, this right here is my b, and this is my m. So my y-intercept is at 8, which is right here. That's the first thing you always graph if you're using this equation. And then from there, you do the slope. Well, my slope is 3, so I rise 3 and run 1. I could also go down 3 and to the left 1. And then I would connect those points. My smartboard, my line is not usually, that's not too bad. You connect those points and you create your line, okay? But again, the m represents the slope and the b represents the y-intercept. And so, if you're given that information, coming up with the equation of the line is pretty easy. This first example here says write an equation in slope-intercept form of a line with a slope of -4 and a y-intercept of 1. Okay, so it gives me my slope, which is my m, and it's -4, and then it gives me my y-intercept, which is my b. So if I take my equation, y equals mx plus b, I'm going to replace my m and my b. So that would be y equals -4x plus 1. Okay, so that is the slope-intercept form for the equation of that line. Now, they typically don't give you just that information. You usually have to find more information. Now, here is the third form that we want to talk about, and this is the point-slope form. Not all teachers teach this method, but I think if you went to school here in Owasso, they did. I don't know about other places. It's just kind of a preference for a teacher. Ms. Namor likes us to teach this because they refer to it on the calculus exam. Okay, so this is the point-slope form, and it looks like this: y minus y1 equals m times x minus x1. Okay, so here is one where everything is plugged in. Okay, this is my x1, and this is my y1. Okay, that's a point that lies on the line. So 3, 5, and then this is my slope. That's the steepness of the line. Okay, so this is the equation for the line that has a slope of -2 and goes through the point 3, 5. Now, typically, we take the point-slope equation and we rearrange it and put it into slope-intercept form, okay? Or standard form, whatever they ask you to do. But sometimes all they ask is for point-slope, and so that's all you have to give, which is like this question here. It says, write an equation in point-slope form for a line whose slope is -1/2 and that contains the point 3, -7. So we go back to the y minus y1 equals m times x minus x1. Okay, so this is my x1, that's my y1, and this is my m. So I plug everything in, and that's y minus a -7, that becomes plus, equals m, which is -1/2, and then x minus my x1, which is a +3. And so if it says put in point slope form, that's all you got to do. You don't even have to simplify it, okay, if that's the form that they ask for. Okay, so how can we put all these together, okay? This one, it says write an equation in slope-intercept form for line L, okay? This right here is line L. Now, if your equation is graphed, okay, you can get a lot of stuff from the graph, okay? Like in this particular case, I can count my slope, and I can look and I can see where it crosses the y-axis, right? Okay? And so I can count my slope, and if I rise 1, 2, 3, 4, and I run back 1, 2, 3, 4, that's 4 over negative 4, which is equal to what? Negative 1. Okay? So that tells me that my slope is negative 1, and I can identify my y-intercept. It crosses the y-axis at a positive 5. Okay? So if I can get that much information and it's asking for slope-intercept form, I'm good to go, right? Okay, because I can replace my m with negative 1, and I can replace my b with 5. So that would be y equals negative, you can put the 1 or just a negative, x plus 5. Okay? But more often than not, it's not graphed. Okay? And it takes a lot of time to graph it, and more often than not, when you guys graph it, it's not perfectly perfect, okay? And you don't use graph paper and this, that, and the other. So you need to be able to utilize your formulas, okay? And so that's what we want to look at now, okay? This one wants us to write an equation in slope-intercept form for a line that goes through the point negative 6, 5, and 2, 1. Should say points, okay? All right, so what we need is we need the slope, okay? And then we're going to use one of these 2 points. Doesn't matter which one, okay? So we want to find our slope first, and remember from last week, slope is the difference in the y's over the difference in the x's. So that would be 5 minus 1 over negative 6 minus 2. 5 minus 1 is 4, negative 6 minus 2 is a negative 8. What's that equal to? Negative 1/2. Okay, so my slope is negative 1/2. So I'm going to use that, and I need to use one of these points. Doesn't matter which one. Okay, these are both positive, so let's just use those. Okay, all right, so now I'm going to plug it into this equation. And then I'm going to rearrange it and put it in slope-intercept form. All right, so I'm going to do y minus my y1, which is 1, equals, my slope is negative 1/2, and then x minus x1, which is 2. That's point slope form. They want it in slope-intercept form, so I need to solve it for y. So I'm going to distribute the negative 1/2. So negative 1/2 times x is negative 1/2 x. What's negative 1/2 times a negative 2? 1. Negative 1/2 times negative 2, whoa, which is, that's a negative right there, which is a positive 1. Okay? All right, then what am I going to do? Add 1 to both sides. Y equals negative 1/2 x plus 2. Okay? So I had to find the slope. Then I used that slope and one of the points, not both of them, just one of them, and I plug it into this equation, and I rewrite it into this form. Okay? Y'all remember this from Algebra 1? Okay. Now, there's always some special scenarios, okay? They're going to give you different things sometimes. Not every problem is a cookie-cutter problem, okay? This one wants us to write the equation of a line through each pair of points in slope-intercept form. So basically the same thing, except for what they're giving us here is the intercepts. Now, we talked about what a y-intercept was. That's where it crosses the y-axis, right? What's an x-intercept? Where it crosses the x-axis, right? Okay? So if it has an x-intercept of negative 3, what's the ordered pair for that point, which is right here? Negative 3, 0, right? Okay, and if the y-intercept is a positive 4, what's the ordered pair for that? 0, 4, right? Okay, so if they give me intercepts, I still need to find the slopes. The slope, okay? So remember your slope is the difference in the y's, so 0 minus 4 over negative 3 minus 0. 0 minus 4 is a negative 4. Negative 3 minus 0 is a negative 3. What's that equal to? 4/3. Okay, so my slope is 4/3. Now, like I said, sometimes they give you a special scenario. They give us the y-intercept. In the slope-intercept form, what is the y-intercept? Y equals mx plus b. Which one is it? It's the b, right? So this right here is my b, isn't it? And we found our slope, so we can just plug it all in. So my slope is 4/3 x plus my b is 4. Now, do they always give me the y-intercept? No. They'll either say it's the y-intercept, or you can look at the point, right? And if the x is 0 and the y is a number, that's the y-intercept, right? Okay? But notice in this problem that we did on the other page, what's the y-intercept? It's 2. Look, the y is not a 2 in either one of those. So you can't just pick a y and use it, right? Because there's 2 different y's here, okay? When there's 2 different y's, you got to find the y-intercept, okay, by using the formula, okay? And a lot of people do that. They'll find the slope and they just pick a point and they just use the y from that point. You can't do that unless it's the y-intercept, okay? Okay, let's do another one. This one, only thing it does is give us the graph. And so we need to find, and we really, almost impossible to tell what that y-intercept is. I mean, it could be a half, but it could be 3/5. It could be a bunch of different things, okay? So what we want to do is we want to find 2 good points. There's a point there. That looks to be a pretty good point right there, okay? All right, and so this point is -1, 2. And this one is 1, 2, 3, 4, -1. Okay? Now, I need my slope, and I could count it, right, since it is already graphed. Rise 1, 2, 3, run 1, 2, 3, 4, 5. So rise a +3 and run a -5, right? So that's -3/5. Okay, then I have to pick a point, okay? So let's just use that first one, -1, 2. And I have to plug it into my formula. Y minus y1 equals m times x minus x1. Okay, so it would be y minus 2 equals -3/5 x minus a -1. Okay, so I'm going to distribute y minus 2 equals -3/5 x minus 3/5. And then I have to add 2 to both sides. So we have to do -3/5 plus 2. Now when adding fractions, what's the main thing you got to remember? Common denominator, right? And so it's going to be what? 5. How could you rewrite 2 with a denominator of 5 so that it was equal to 2? 10/5, right? So that would be -3/5 plus 10/5, which is what? 7/5? Okay. So my equation would be y equals -3/5 x, was it plus? Yeah, plus 7/5. Okay. Now you're like, fractions, okay? You got to get over that. You got to get better at them. You got to get quick at them. You got to know that to add and subtract, you have to have a common denominator. To multiply and divide, you don't, okay? You know, I teach that ACT prep class, and one thing that I've learned is that you got to be fast. You can't be multiplying 1 times -1 on your calculator, okay? Or using the calculator to add 3/5 and 1/2, okay? You got to be fast, all right? You get 60 questions, you get 60 minutes, and some questions take more than a minute, and some should take a whole lot less, okay? So don't be so dependent on your calculator, all right? Try to get that basic stuff without it. Okay, now, other special situations is when we have horizontal and vertical lines, okay? Now, a horizontal line goes like this, right? Okay, like the horizon. What axis does it go through? It goes through the y-axis, right? So the equation for that line is going to be y equals wherever it crosses the y-axis. So see how this right here is horizontal? And do you see how it goes through the y-axis at a positive 3? So this equation is y equals 3. Okay? Now, I had a student back in the first or second year that I taught that was really smart. He was like in Algebra 2 in the 8th grade. And what he told me is he takes the y, turns it upside down for an h, and that way he knows it's horizontal. That was his little trick that he used back then. And I don't know why, I've always just remembered that. That's one way. The other thing is, what was the other? Oh, for x, the line that goes through the x-axis is vertical, right? So if you cut the x in half, you get a v. So anytime it says x equals something, you know it's a vertical line through this number. So x equals -2, you would go to -2 on your x-axis, and you would draw a line through it. Okay? So y equals is a horizontal line, okay, going through that number on the y-axis, and your vertical is going to be x equals some number, and it's going to cross the x-axis wherever it tells you it's crossing at. Because no matter what x is, y is going to always be 3. So x could be what, -4 or 5 or whatever that is, but y is going to be 3. Okay? And the same thing here. No matter what y is, x is going to be -2. Now, what is the slope of this line right here? Think of skiing. Slope. Huh? Undefined, because can you ski like this? No. Okay, you cannot. You would die, right? So it is an undefined slope. Okay? A horizontal line has what kind of slope? 0. You're not going up or down, right? You're just making go straight across, right? So this one has a slope of 0. This one has an undefined slope. Okay? So keep that in mind. We're going to now do some more where we have to write an equation of a line that goes through the following points. Okay? Now, what we need from this is the slope, right? So if we find the slope, we're going to do the difference in the y's over the difference in the x's. 6 minus 6 is 0. -2 minus 3 is -5. What's 0 divided by -5? 0. And if you don't know, put it in your calculator. Okay? It's either going to give you a 0 or it's going to give you an error. Okay? This is going to give you a 0. What kind of line has a slope of 0? Horizontal line, right? Which means it goes through the y-axis. So we know that it's going to be y equals, and look at what the y is for both of those. It's a 6, right? Okay? So that would be y equals 6. That's a little shortcut for you. Okay? Now let's look at this one. Again, we want to find the slope. 3 minus a -1 over -4 minus a -4. 3 minus a -1, 4. -4 minus a negative is what? 4 is 0. What is 4 divided by 0? You put that in your calculator. It is going to say error. So this one is undefined. What kind of line is undefined? Vertical. And what axis does it go through?
X.
X. So we know that it's going to be x equal. And looky here, both of those are the same number, right? Okay, so it's x equals -4. Now, if the slope is not 0 or undefined, okay, you got to plug it into the formula, okay? Also, if you don't know the y-intercept, you got to plug it into the formula, okay? All right? Don't forget that formula, y minus y1 equals m times x minus x1. All right, so nothing new, right? We all learned this last year in Algebra 1, yes? Okay.